We ready? Great. Good morning, everyone. Thanks very much for coming. So I'm Pierre Meunier, and I've got Dave Shepherd with me today. So we both platform engineer at Wells Wizard. Today we're here to talk to you about how we use Istio traffic management into our release pipeline. So we'll go through a bit of a background of who we are, what we do. We'll look at the problem we were facing a little bit less than a year ago with our release pipeline, the solution we came with, some of the tools we wrote to support that solution, and the gains and the pains of going through the process of introducing Istio, and a quick summary at the end, and hopefully some questions as well. So we are Wells Wizard. We are a little fintech in Leamington Spa in the center of England in the UK. We are regulated robo-advisors. Robo-advice just means that we use technology and algorithm to automate the generation of financial advice. We focus primarily on pensions and retirement advice. We also have some financial well-being products available direct to consumer or through employee benefits. Our vision is financial advice for everyone. We want to make it affordable and accessible to everyone. We're not just an engineering company. We do have practicing financial advisors at Wells Wizard as well, which helped greatly when we come to write our product. A key element is that we are FCA regulated. FCA is the Financial Conduct Authority. That's the UK body that controls everything related to financial services. So it means that we are in a regulated industry. It means that there's a lot of rules and regulation, and we need to make sure that we give accurate advice, and we need to make sure that we follow the rules. And we'll see a bit later how this has impacted us. We use the microservices architecture. We've got a growing number of services. We deploy them for multiple tenants. So it does mean that sometimes some services are duplicated in between those tenants. We also have a common namespace with services shared across all those tenants. We keep our microservices small. We want them to solve just a single purpose or a single concern, whether it's a business functionality or technical functionality like generating a PDF or a docx file. So size varies, but we try to keep them as simple as possible. And we want to avoid duplication of code between services, and instead we have services talking to each other. For some of the cross-cutting concerns like security and logging, we don't want our engineer to have to worry about those. So we try to push them down into the platform as much as we can. And we are hosted on Kubernetes.
So we chose Kubernetes for probably the same reasons that everyone else did. It gives us a lot of flexibility whilst providing us with a way of running our microservices reliably. And we started probably over 3 years ago. We used the good old kube-up script to set up 2 clusters, one for our production systems and one for our non-production systems. And we kind of went and upgraded from there from about, I think it was about version 1.2. We just kept going up and up to the later versions. We're really keen on having all our infrastructure as code. So we build stuff out starting with Terraform to define our sort of networking bits and pieces in AWS, and also anything that's not kube related. And then we use kops to deploy and manage our clusters on top of that. We keep all the cluster configuration and our namespace configuration in our source repositories so we can reapply them easily. And then we've got some custom tooling for deploying our applications in a consistent way, because we want our engineering teams, our development teams to only worry about the bits they need to worry about whilst deploying everything in a very consistent manner. And most of our applications are very similar in terms of their requirements for running on Kubernetes. And this was back in the day. We introduced this before Helm kind of came about, so we haven't really moved away from it yet. And we wanted to keep that automation in place and all that infrastructure as code, because it gives us confidence, gives us the ability to repeatedly bring up clusters if we need to. And that kind of worst case scenario, if we really had to, and we lost a Kubernetes cluster, we could just rebuild it within a couple of hours. Luckily, we've only ever done that as an exercise rather than because our production system went down.
So our platform has evolved over time. As Dave said, there's a lot of new tools coming out a lot of the time with Kubernetes, and some of the tools that are available now were not available then. So we have to write some of those ourselves. We still use some of them now. Our deployment process is pretty much a mix of Bash script, console, Vault, and some JSON configuration, and it still works quite well, so we're quite happy with that. We have a fairly standard CI/CD pipeline, so all the commits are built, tested, unit tested, component tested. We do some security checks as well. And when we build onto master, we also create a Docker image, and we push that automatically to our dev servers. For our staging and production lack environment, we still have a push of a button, and we're quite happy with that process. Self-service is also something that's quite important for us. We don't want to have our engineer to have to rely on us to do some deployment or anything related to production environment. So instead, we try to provide them the tool so that they can do all their work without having to require on our time. So a few examples, we've got one there. So we created a chatbot for them that we called Conan the Deployer. So just a little example there. At Conan deploy, you choose your service, your environment, and a reason, which is often a ticket number. And that lets the engineer deploy any services to any environment, including production. We have also the configuration is like a bunch of JSON files, and engineer can control the versions of the service that goes to different environments, can control the configuration of those services and where to find the secrets for those services as well. But we are in a slow-moving industry. That's one of the reasons why we got into this in the first place. We want to make it a lot quicker. And it means that sometimes we can't push to production as often as we like, and often is due to compliance check and regulation checks. To give you a simple example, just to drive the point, is if you take the simplest change that you can think of, so say just changing a bit of text in a document that you're going to send to your customer. From an engineering point of view, it's very simple. You change some text, it goes through your pipeline, you have some test, it goes to production. Typically, within hours, maybe less, you can get that onto your production. But from the compliance side of things, changing a sentence might mean that you will change the advice that you're giving to your consumer. And potentially, we might break some regulations. So there's a lot of testing that needs to happen on that side of the business. So we want to deploy quickly, but at the same time, we have to comply with regulation, and there's a bit of friction there. So, as I just said, we must comply with regulation, so our pipeline looks like this. When a feature is dev completed, we have a standard code review process, which is just pull request system, really. That gets merged into master. We've got automated build that go to our dev environment, and then you've got the pretty standard QA review, some automated test that runs on top of that. We then have the very important compliance check, and then we can push that into our production environment. So it's a very linear process, and when everything is fine, just a tick in the box and it's in production. However, if we have any problem with any of those steps, especially the compliance check, then we're now blocking all the release that are coming to our production environment. We now have a master build that is corrupted, and we find sometimes that compliance check could mean that we needed a couple of days to fix those. So it's a very risky position. We kind of breaking the continuous delivery principle as well with this. So we started to look at options.
So the first sort of way around this sort of problem was to introduce the idea of feature flags, and we did experiment with this a little bit. And the problem we mainly found was that the overhead in doing this, introducing code like this into each of the microservices that a change potentially affects, started to become more work than the change. So the example that Pierre just said, a one-line change, which to an engineering team is very simple to do, but adding the feature flag on top of that makes it more complicated. But it's the sort of change that is most likely to cause a problem in terms of compliance. And therefore, things would start not getting the feature flags around them, and then we still end up with the same problem. With another option is around sort of beta users, where it's a very similar argument. The application itself needs to know about whether a user or a feature flag is enabled or a user is allowed to use that, and then the code has to kind of deal with that. And when you're introducing these variables, you then have to test every combination of these flags or these variables in order to make sure that you're not breaking existing code. So one of the things we do anyway, our engineering team will have the ability to spin up parts of our system locally, and they'll either interact with mock endpoints or they'll interact with some of our development clusters. And that kind of works well for the small iterations the engineering are doing. But once you start handing stuff over to our sort of compliance teams to check, they don't really want something that's very tech heavy to deal with. So we start being asked to spin up environments because we want to test a feature. On top of that, we might get asked to environments for all kinds of different reasons, maybe demonstrations or just for playgrounds for people to explore it, or just because they like to annoy the platform team a little bit.
So in a monolithic world, when you get asked to duplicate your environment, you tend to have like a single big artifact. So if you want to duplicate it, it's fairly easy. You just spin up a new instance, whether it's on the laptop or on a server somewhere. It doesn't really matter. And if you ask for some more, you just add more. And if you ask for some more, you add more. In our microservices world, well, we could do the same, really. We know that it's very simple to deploy services with Kubernetes. And if we ask for some more environment, we could also duplicate them. There is, however, a cost into infrastructure, obviously. It gets a little bit more complex as well. But we also find that there was a cost in time in managing all the configurations for all those environments. And also there was a lot of duplications between all of those. So that wasn't really quite the right way to fix that. So instead we thought, why not just spin up the bits that have changed? So I've got my macro services world, and if I've changed only a couple of services, why could I just not run alternative versions of those services alongside the master version and find a nice way to route traffic to the services? And that's where we started to look into Istio. So we've been to quite a few talks. Istio has come up an awful lot this week. It's just one of a number of service meshes that are very much high on the radar. And we've been aware of Istio for probably a couple of years. In fact, we played around with it a few years ago and just found it had so much potential and a lot of features, but we didn't really have a problem to solve at that time that we wanted to introduce the complexity in learning it and running it. And then this problem came along, and we thought we'd give it a go, and we're going to use the traffic management sort of features of Istio to solve our problem. So as you're probably all aware, if you've been to any of the other talks, this is how Istio works. So we have service A talking to service B. You get a proxy sidecar injected into the pod, which is Envoy, and that handles the communication. So service A goes via the proxies to service B, and those two services don't know anything about it. And that allows you to add various rules for that traffic, either sort of encryption or traffic routing rules. And then all this is managed by the control plane at the bottom there, which makes sure that the Envoy proxies know what's going on. So in the traffic management world, without Istio, if service A talks to service B, it just gets routed to any of the pods within that service. When you introduce Istio, you can start doing some rules, and we're going to talk about the HTTP headers. So in this example, we would look at user agent set to Android, which would get route to the current version of service B, and then a user agent of iPhone would get routed to the canary version of service B. All the while, those services running don't know anything about it. So I'm going to run through a little demonstration of how we've implemented this, how this works from a developer's point of view. So this is our Robo Power Planner application. This is what some of the financial advisors will use to generate financial advice. And we're going to imagine that we've picked up a piece of work to rebrand our application.
So this is running in our development environment. We call it Green, and that's the name of the brand of the application. We're going to rename it as part of our new brand. And as we'll find the bit of code that we're going to change, which is just there, we're going to rename it, and we're going to use Dave, because all good engineers use their name when doing demonstrations. So I'm going to commit that to our source repository. We're going to use the ticket number that we're doing this work on, which is going to be ops1234, in the name of the feature branch that we're committing this to. And then when we push this to our remote repository, our CI system kicks in, does its usual build, testing, linting, etc. But the last step it does is actually deploying this to our Kubernetes cluster. So I'm just going to bring up a new window, and I'm going to use a little plugin for Chrome. And this plugin will allow us to attach HTTP headers for the browser requests. So I'm setting X variant ID to the ticket number we used in the branch name, which is ops1234. So if I enable that and I refresh this page, we'll see that my change has now been deployed and I'm being routed to it. So you can see my names there in the middle. And we thought this was great. Our engineers thought this was great. But one of the things that was missing was being able to give this to our compliance teams who are not necessarily technical. So rather than getting them to install a plugin, we introduced the ability to do this through the host name. So we also allow prefixing the host name there with the same ticket number, and you can see that comes up with the same variant, even with the headers disabled. And just to prove that our mainline version, our master version is still running, I've refreshed that page and we've still got the existing application running in parallel. I'm going to talk a little bit about the Istio configuration that makes that possible. The first one is a destination rule. So destination rule is basically defining subsets of a Kubernetes service that we want to be able to route traffic to. So in this case, our service is FactFind UI, and we've got two subsets defined. One called ops1234, which is looking for labels on the pods for that service, called version with the value of ops1234, and then we have a second destination rule which is looking for the label version set to master, and it's just called master. The actual logic for routing traffic then comes to the virtual service in Istio, and we've actually defined two virtual service, one for ingress, which is determining how external traffic to Kubernetes is routed, and we can do hostname routing, and then we also do virtual service for the mesh for service-to-service communication within our cluster. So the first one I'll show you is the ingress. And this is telling our Istio ingress gateway how to route traffic. And we're going to add a rule to match on authority, which is effectively the host name. So I'm looking for ops1234 and then the rest of our domain name. And if that matches, first thing we do is append a X variant ID header with the same ticket number, which I'll talk about in a second. And then we route it to the destination service, giving it the subset that we defined on the previous slide of ops1234. We have a second rule, which is basically doing the same thing, but only matching the HTTP header. So we can use both options, and the header becomes more important when we're talking downstream within the Kubernetes cluster. And again, routing that X variant ID header to the same subset. And then the final one is a route, default route. So and no matching rules, anything else is sent to our master version. And with the destination rules on this, you can have as many subsets and routing rules as you need. And then the internal traffic, so anything going from service to service within Kubernetes is defined in this mesh virtual service. And this is only matching on the variant ID, because when you're talking internal to the cluster, we're using internal service names. So there's no easy way of us to inject that without our application starting to know a bit more about it. How was this managed? We wanted to basically make this feature available to our engineering teams without them really having an overhead in doing this. So we wanted to automate this, make it happen for all our microservices on all our feature branches. So we had to introduce automation to manage this. So the first one is how they're deployed, and this was quite a simple change for us because we already had CI on our branches anyway. We just added a step to the end to deploy that variant or that branch to our Kubernetes development cluster, and we're already deploying on whenever we build master anyway, so this was a small variation on that. At the other end of the process, we wanted to tidy stuff up because we didn't want these branch deployments or variant deployments being left lying around. So we just introduced something we call Kube Housekeeper, which is effectively just a Kube cron job that goes and cleans up branches that have been left lying around for a few days so that we don't use too much resource. The big piece we added was something we call AutoCube, and one of the problems we had with Istio and the declarative way it works is that we needed to know about all the subsets or all the deployed versions of a particular service in order to generate that destination rule YAML, the virtual service YAML. So we wrote a little tool which is kind of based on console template, primarily because we already stored a lot of information about what's running on Kubernetes within console to generate those YAML files for every variant that's currently deployed. So every time a new deployment happens, it gets added, and when a deployment gets removed, then that also tidies it up as well. And so we introduced that, so that's constantly monitoring our cluster.
So the next one is Edge Propagate. Edge Propagate is actually a Node.js module that we had to write. Most of our services run in Node.js. And fairly early on, we recognized that we would have a requirement to propagate headers through our services. So if you got services A, B, and C, A talks to B and B talks to C, we do new features and you have changes in A and C. When we send requests with our X variant ID to service A, we now need service A to propagate that header to B, and we need B to propagate that header to C as well. So a simple change would be to go through all our services, all our endpoints, and start to handle that manually, but obviously that didn't feel like the right way to solve this. And then we thought of how library like New Relic and Elastic APM managed to do their stuff. So I'm not sure if any of you have used New Relic before, but in the Node.js world, you import or require the New Relic module. It instruments your code, and then you start to receive data in New Relic. So we thought that's quite a nice way to solve that sort of problem. So we actually looked in the code a bit more. It turns out that it's a bit messy and quite difficult to get right. But we look a bit further, and I think some of the committers in the Elastic APM project have released some nice videos and a presentation about how to do this. And it turns out with Node.js now, it's a little bit easier to do. They've got a core library called async hooks, and that lets you get notification into a synchronous event. So what that lets us do is effectively, in our service, when an HTTP request comes in, we get a little notification. We can go and look at the headers, grab the value of the X variant ID. Similarly, when we have outbound HTTP requests going out, we also get a notification, and we can inject the header into it. Another cool stuff with that library is that you can link the outbound request to the incoming request, so you can map which headers needs to go to which request. And then with that, we started to have, so our service propagate the header automatically. It does need a little change in your code, so that's the first line there. So you just require edge propagate, and then you start to have your headers being propagated. We also added the correlation ID header, which we use to do debugging across multiple services. And now that we used Istio, we also looked into the Istio observability, and you've got a Jaeger and request tracing. And Istio handles some of those headers for you already, but there is one requirement in your service is to propagate some headers. So we just wrote edge propagate at the time, so we added the 6 headers, I think, that you need to have your tracing, and we started to receive traces almost for free. So that was quite cool. Okay, so let's look at the gains. So 6 months later, and that feature has become really indispensable, especially for one of our team who works a lot with regulation and compliance. So they don't have to worry about dependencies between their features anymore. They can just have a feature deployed in the branch, and they can QA test in isolation. They can compliance test in isolation as well. So we also brought the QA team and the compliance team a bit earlier in our pipeline, which I think is actually an improvement. And a nice added bonus as well now is because we do so much testing on the branches that once we decide to merge, the merging is really smooth now, and we just go through a few regression tests and compliance tests again, obviously, but we are now able to release to production a lot quicker than we used to. As another example, very recently we've introduced a new user authentication mechanism into that project, and there was quite a lot of work involved, and we managed to isolate that in the branch. We were able to evaluate the product that we were using quite well without affecting any other features going into production. And again, it was well tested, and once we were ready to use it, we merged, and very quickly, within a day, we had that to our customers. So very successful for us. But it's not been easy, to say the least. Istio is a great product, but it's quite complex. There's a lot of moving parts. On top of Kubernetes, that also has a lot of moving parts. The traffic management affects the networking, so a core thing into your infrastructure. So when something goes wrong, you can have some quite important impact. There was a steep learning curve. We have struggled to find out how to configure the pilot and the control plane properly to support our configuration. And we had quite a lot of stability issues. In hindsight, I think we were under provisioned for what we were trying to, the number of services that we were trying to support. And when the control plane was under load, we started to receive at some point quite a lot of 503 errors. And that was only impacting our dev environment, but we did impact our engineer at the time. And we were not very popular at that time. And we almost backed out of Istio at that point. But the deploying into a branch was so powerful for one of our team that we stuck with it. We got to know Istio a little bit more and a little bit better. We've also upgraded, as there were quite a lot of bug fixes committed by the Istio team, to the point now that for the last 6 months it's been very stable, and we're really happy with it. And we're actually now thinking of pushing Istio into staging and production and start solving different problems with it.
So Istio has been a huge improvement in terms of unblocking our release train. We think our engineering teams find it indispensable and are using it an awful lot, because it means we can do all the stuff that would previously be in our pipeline after we committed or merged our changes into our mainline. We can do that before that, and now we can release into production within a couple of hours of doing master, because all we do is a few regression testing at that point. Whereas in the past, we'd do a change, and then any problems would then block any other changes potentially. And the really fantastic thing about it is the microservices themselves don't know anything about this. Other than the hpropagate stuff, we haven't had to introduce anything at all into our microservices, so they are nice and simple still. So we think Istio's got an awful lot of potential, and as Pierre said, we're going to extend its usage now. I think we're much more comfortable with it, and it's a little bit more stable, but it does come with complexity, particularly when it doesn't do what you're thinking it should do. So I'd like to thank you very much. Some of the projects we've been doing are on GitHub, so if you want to have a look, some of them you can maybe use out of the box, others you might just want to see what we're doing. But thank you very much.
Yes. Thank you.
Yeah, we do have time for a few questions, and I already see first one.
Hi, thanks for the talk. Are you considering to add any API gateways?
Please, everyone, well, either leave quietly or don't leave at all when the questions are being answered or asked.
Like Ambassador, Kong, or any other in front of your Istio service mesh?
Sorry, would you mind repeating that? I didn't quite catch it.
Can you repeat the question?
Are you considering to add any API gateways like Ambassador or any other like Kong in front to manipulate with headers, rates, and other things with, that these features in service meshes are not usually happening. So that's why you are workarounding a bit.
Yeah, we've got API gateways on our radar. It's something that our engineering team are exploring, and we'll probably implement something in the near future. But I think the real power with the Istio is the in-service within the mesh, kind of routing pod-to-pod kind of traffic.
Hi, thanks for the talk. How do you handle state? Do you have state that you need to isolate?
The stuff we deploy is almost exclusively stateless, so our persistence is in Mongo clusters outside of Kubernetes primarily. Hi.
Are there any firewalls, or are these custom DNS all publicly accessible, or is it only internally?
They're internal, so we use whitelisting within ingress gateways to prevent access to our development environments. Some of them are accessible to our customers, so they are allowed access, but only from their IP addresses, so we do block access to these test environments.
Hi, thanks. I mean, maybe piggybacking a bit on the state question. Even with Mongo or with other databases that you have, how do you handle when the feature you're testing might require a DB migration, which is non-breaking but still affects the state of the current database? So
this is a problem we're currently tackling. When we introduced this, it wasn't long before someone wanted to do a change to the Mongo schemas that we're using, and that started causing us headaches. We've got a couple of ideas. One of them involves Istio in terms of migrating through to production and running multiple versions of the same service with different schemas. But within our development environment, we're looking at actually just pushing to collections or databases that have a different ticket number or something, a branch variant ID in it, so we can spin up effectively a database quite easily, because Mongo, a database is just when you persist to it, it exists, so we can just do that quite straightforward.
In terms of your compliance testing, is it manual or is it automated?
We automate as much testing as we can. We do some exploratory testing, which is manual, but we have quite a good QA team that will work with our engineers to come up with the test suites to make sure that we're meeting the criteria. Because we're a regulated industry, we need to be very sure that the test results reflect what the requirements are, what the compliance requirements are. Recommendation on tools. I don't know what we use off the top of my head. Do you?
We can find that though if you want to.
Yeah.
We can ask our QA team. Yeah.
Thank you. Have you had the chance to do some performance analysis on this approach of using Istio and splitting the traffic?
Not explicitly. So the issues we had when we first started trying to get this to work was around the control plane, and actually it was a lot more resource intensive given the number of pods and services we were running. In terms of the traffic, we're not seeing a particular slowdown, but performance isn't our highest requirement at the moment, particularly in our engineering environment. There was some talks that I've been to over this week that talk about comparing, and although Istio does seem to be a little bit slow in many cases, it's like comparing apples and oranges, because Istio is doing different stuff potentially to other service meshes.
Thank you for your presentation. About the ingress that you're using, are you using any kind of ingress, or are you using the Istio gateway?
So we use Nginx ingress initially. That was we had that prior to Istio. Then anything we want to use Istio with gets routed to the Istio gateway, which handles the routing. And the reason we've kept the Nginx ingress there is because it provides a lot more functionality. We had a lot of rules. We talked about whitelisting a second ago. We've got rules around allowing our monitoring tools into our network, things like that, and a lot of the security requirements that we've introduced, like cross-site scripting headers and stuff like that. We've done a lot of work in the Nginx to do that, and it's very customizable, so it sits there still.
Thanks for a very nice talk. And what you describe here looks like it works very nice for HTTP communication between microservices. Do you maybe have any like a messaging communication as well, and you have a solution for that as well?
We're primarily HTTP. We have a couple of messaging services, but that is an area that we want to expand. So we haven't really solved any of this sort of requirements in the messaging area.
Okay, thank you again for the talk.
Thank you very much.
And it's a lunch break now.